Okay, welcome back to math class and welcome to part 2 of 10-6. In the first half of 10-6, we talked about what happens when two secants intersect inside of a circle and what happens when a secant and a tangent intersect on the edge of a circle. But today we're going to talk about what happens when secants and tangents intersect outside of our circle. So, first things first, we're going to look at what happens when we have two secants and they're intersecting outside of a circle. So let me draw our circle. Here's our external point. One secant, two secants. Okay. Now what you'll notice is that we have 4 intersecting points on our circle. And I'm going to label them A, B, C, D, E. Okay, now what we can tell, looking at this, what we know is that this angle right here is going to equal 1/2 times the big intersected arc minus the little intersected arc. So CE minus BD. Now all of that is going to equal the measure of angle 1, or the measure of angle A. So no matter what these two angles are, or what this one is, we can figure out A by doing the bigger arc minus the smaller arc. So let's just plug some numbers in and see how we do. If I say, find for me angle A, and this arc is 70, and this one is 32. Find for me the measure of angle A. What I'm going to do is I'm going to take 1/2 times 70 minus 32. 70 minus 32 is going to give us 38. So 1/2 of 38 will give us 19. So the measure of angle A is 19. Pretty straightforward. Hopefully that makes sense. The second thing we're going to see this time, or in this lesson, is not just two secants intersecting outside the circle, but what if it's a secant and a tangent? So I'm going to erase the second secant and make it a tangent instead. If you guys remember the difference between a secant and a tangent, a secant intersects the circle twice, a tangent only intersects it. Yikes. A tangent only intersects it one time. So it's only going to have one intersection point. Okay, what we can know about a secant and a tangent is going to be, it's going to be the same. Our angle measures, the measure of angle A is still going to equal 1/2 of my big arc CD, minus my small arc, BD. Oh, minus. So same as before, when we had two secants, we did our big arc minus our small arc. We're still going to do that this time, and they're just going to be bigger numbers this time. So say this is more like 120. Let's look at, I'm asking you for what is BD. What if I gave you that this was 120 and this was a 30-degree angle? What I would do is I would put in 30 on this side equals 1/2 times 120 minus BD, and we'd have to do our algebra to get BD by itself. So the first thing I'm going to do is multiply both sides by 2 and get 60 times 120 minus B, or 60 equals, I don't know why I said times. 60 equals 120 minus BD. Let's go ahead and we'll add BD to both sides. And then we'll subtract 60 from both sides. BD equals 60. Pretty straightforward. Hopefully we're still making sense. The last one is just a tiny bit different. And it's going to be, what do we do when we have two tangents instead of a tangent and a secant? I'm going to erase this top one here and put A back. Now again, a tangent just has one point of intersection. Just like we had one here, we have one here. Now what you'll notice is that this time we have basically the whole circle, but that doesn't change the formula that we use. We're still going to do the big arc minus the small arc. This time it's just going to be all of our degrees for the whole circle. Okay, so we're still using the measure of angle A equals, we're going to have to add ourselves another point so our labeling is clear, equals the big arc BCD minus the small arc BD, and all of that times 1/2. So this whole time it's been the same equation, big arc minus small arc, but it's going to look different based on whether you have a tangent and a tangent, or a secant and a secant, or a tangent and a secant. You have to be able to recognize which one is which and plug those numbers in. So this time, let's try if I gave you that this was a 45-degree angle and this one is a 70-degree angle. Let's try plugging that in. The measure of angle A I gave you was 45 equals 1/2 times BCD minus 70. All right, so we're going to multiply both sides by 2 again and get 90 equals the measure of BCD minus 70. So I'm going to add 70 to both sides and I'm going to get 160 equals BCD. So you're just doing basic addition and subtraction. Hopefully that's relatively easy to understand. If you have any questions, feel free to let me know.